Okay, so this is the calendar. Notice we're going to do 13, 1, and 2 this week. Monday, District 49 wants us to take a rest day to catch our breath before we jump into semester finals. We'll start taking semester finals in that third week there. Notice on that Monday and Tuesday, or Monday and Wednesday, we'll do a semester review for geometry, and then on that Friday you start your finals. Now that weekend after your English comp exam, not English lit, but English comp, that weekend after that is a 3-day weekend because of Memorial Day. We come back and we take our remainder of our classes. So just so you know, it goes, let's see, on Tuesday you'll take your biology, Wednesday will be Latin, Thursday will be math and English lit, and then Friday will be history. That's how the schedule will work. Okay, so you got a total of what, six finals you have to take. If you have any specific questions, go ahead and email me. All right, here's your homework tonight. Tonight's a pretty cool class. There will be nothing you don't understand. Trust me. Okay, so we're going to jump into something called the distance formula. And like I said, since I had you last year for Algebra 1, this is something we covered in Algebra 1. It's also something done in pre-algebra as well, too. So for those I didn't have last year, you should have been exposed to the distance formula in pre-algebra. All right, so we'll just jump right into it. Here we go. Not to insult your intelligence, but okay, I will. Remember, the origin is made up of many parts. The coordinate plane is made up of many parts. At the center, where the two number lines come together, or the x and the y, is the origin. We have our two axes, the x and the y. We have our quadrants. Remember, it goes counterclockwise, starting with the upper right, 1, 2, 3, 4. And yes, it is customary to use Roman numerals to indicate your quadrants. Okay, so to refresh your memory of what the distance formula is, think about this. Okay, if I had 4 points, you see the 4 points there, A, B, C, and D. So I'll look at just A and B. So the distance between A and B, well, it's already indicated there is 4. Well, how do we know it's 4? Well, it's literally 4 ticks on the number line, on the x number line, away from each other, right? B is at -1, +4. A is at 3, 4. And if I simply just count the number of squares, there's 4 squares, or 4 lattice points away from point A to point B. Okay, well, that works great. So it turns out that you can, if you have a horizontal line, you can figure out how long it is simply by counting, right? So it's 4 units long. Well, mathematically, there's another way we can do it. If this was a number line, and it is a number line, by the way, A is, remember, points are made up of an x and a y. If I just look at the x coordinate, because it's a horizontal line, if I look at the x coordinate of point A, it's at 3. And if I look at the y coordinate, it's at -1. How far is it between -1 and a +3 on the number line? Well, that's 4 units. Remember, I could also get that by using subtraction. If I subtract from 3, the farthest to the right, if I subtract the other point on the number line, I also get to 4. 3 minus -1 is a +4. If we go at the other direction, if we go left minus right, so the x-coordinates, left minus right, -1 minus 3, well, we don't get 4, we get -4, and that's a problem. So what we say is that the distance between any 2 points on a number line is the difference of their absolute value. And so now life is good, we get +4. Okay, so if I do -1 minus 3 and then take the absolute value, I do in fact get 4. So the distance between any 2 points on a horizontal line is the difference of their x coordinates, and then take the absolute value. Make sense? Okay, well, what about if we have a vertical? Look at C and D. Notice that's a vertical line, okay, or a vertical line segment. So how far is it between C and D? Well, it's the same thing. So if we do the absolute value of not the x coordinates, but the y coordinates, right, 1 minus -2, right, or the absolute value of that, we would in fact get 3. And we can certainly count the little units as well, too. 1, 2, 3. Make sense? Okay. Well, we got a problem. Well, what happens if we have not a vertical, not a horizontal line? We have a diagonal line. How do we calculate the distance between those 2 points? Well, luckily for us, we have a method to do this, right? And it comes from previous chapters. A long time ago, we talked about the Pythagorean theorem. Remember the Pythagorean theorem? Well, the Pythagorean theorem deals with not line segments, but with right triangles. So let's make a right triangle. Notice if I not connect the 2 points, but I go to the left from the bottom point and go down from the upper point, where those 2 red lines would intersect would form a right triangle. Well, now the red portion is now a horizontal and a vertical line segment, and I can literally just count boxes again, or count little lattice points. So it's horizontally it's 6 units, and vertically it's 10 units. And then I could just use the Pythagorean theorem there. So 10 squared plus 6 squared would equal my distance of that line segment. Makes sense? Okay. Remember, you can always do this. For any line on the coordinate plane, you can make a right triangle and simply use the Pythagorean theorem to calculate its distance. That's kind of useful. Well, let's finish this one. Let's see. That would be 100 plus 36, and the square root of 136 is, let's see, well, is there any perfect square that goes into that? Turns out 4 does. That one's a little bit hard to see, but 4 goes into it, so 2 root 34. All right, so the distance of that black line segment right there is 2 root 34. Tonight for homework, when they have you calculate the distance, I want you to leave all of your answers in reduced radical form, if it's a radical, right? Not all of them will be radicals, but don't pull out a calculator, okay? All right, makes sense? So what is this good for? Well, obviously we're going to make this into a formula to allow our life to be a little bit easier. So if you remember the distance formula is simply an application of the Pythagorean theorem. So notice here, I don't have any numbers there. I just have coordinates. I've got P, Q, and, well, there's an R there now. So in order to calculate the distance of PQ, I'm going to use the Pythagorean theorem. So remember, a squared plus b squared equals c squared. The challenge here is I don't have any numbers there, but I do have variables for them. Notice on point P, we're going to call the x value x1 and the y value y1. For point R, x2, y1. Right? Well, wait a minute. Why is it still y1? Well, notice there is no difference in the y values of point P and point R, because they would be horizontal to each other. Does that make sense? I mean, certainly the x values would be different, but the y values would be exactly the same. Now take a look at point Q. Notice point Q and point R share an x value, but they do not share a y value. So this one, point Q, we'll have to call x2, y2. Okay? So now let's apply the Pythagorean theorem. Now it doesn't matter which one you call point A, point B. I'm going to call PR, I'm going to call that the A value, and I'm going to call QR or RQ, I'm going to call that the B value, okay? Obviously PQ would be the C value. Notice it's labeled suspiciously, it's labeled D, so we're going to call that distance, I just gave it away, we're going to call that distance D. All right, so we're going to apply what we just learned. We just learned that if you want to know how far something is left or right, horizontal, you take the x values of the 2 points, subtract them, and take the absolute value. Okay, so that would be what? x2 minus x1, then take the absolute value. And if we want to find the vertical distance, we look at the y values and subtract them. That would be y2 minus y1, take the absolute value, and that is what we're going to throw into the Pythagorean theorem. Now notice it looks very messy, okay? But that's what I did. Notice, look what I put in for a squared. Well, we can see the squared, and then what did I put in for a? That would be the distance from P to R. That would be x2 minus x1, and then take the absolute value. Make sense? And then the distance of RQ or QR would be y2 minus y1, take the absolute value. Okay, I got to square everything. So, and why is it d squared? Well, remember, it's a squared plus b squared equals c squared. We're calling c squared now the value d, so I squared d. If you need to rewind, play that again, please do. Okay, we can do one extra thing here before we start doing the math. Think about this. Let's say that the answer to x2 minus x1 was -3. Notice the very next step I would do to that would be to square it, so I would get a positive value. So that absolute value symbol does not really play a role here because I'm going to square the difference. I'll say this again. Notice I'm doing x2 minus x1. I don't care if that answer is positive or negative because the next thing I do is square it, and that will immediately make the answer positive. So it wouldn't be wrong to leave the absolute values in there, but I'm going to choose to get rid of them because I know when I square their difference, right, x2 minus x1, doesn't matter whether the answer is positive or negative, because when I square it, that answer will be positive. So, mathematicians are efficient, not lazy. We're efficient. We're going to leave off those absolute value symbols because when we square, it gets rid of the negative. Okay? All right. I'm going to do one last thing, right? Remember, the original problem was how long, right? What is the length of a diagonal distance? Well, that was the value d. So I'm really trying to solve for d. So right now it says d squared. So I'm going to get rid of that d squared, the square portion, and take the square root of both sides. If I take the square root of both sides, well, obviously the d squared becomes d, and the other side, well, since it's nothing but variables, I don't know what it turns into, so I simply put that whole thing underneath the square root symbol. Okay? By the way, ladies and gentlemen, that is the distance formula right there. So, if you want to find the distance of any 2 points, you take the square root of the square of the difference of the x values and add that to the square of the difference of the y values. That's a lot to say. The formula is easier to look at. Oh, by the way, that was a proof, right? I showed you where the formula came from using logic, right? Every step was justified. We call that deriving a formula. When I show you where the formula comes from, right, we call that deriving the formula. And by the way, this is Theorem 13.1. It's called the distance formula, and it says the following. The distance d between these 2 points, x1, y1, and x2, y2, is determined by the formula d for distance is equal to the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Okay? The number one question I always have asked of me is, why is it x2 minus x1 instead of x1 minus x2? And here's the real reason. It doesn't make a difference. Right? You get to pick which one is 0.1 and 0.2. So if I pick my 1 point to be 0.1 and you put that to be 0.2, then you've just flip-flopped, and it still works out with the same math. I'll show you an example where we do it both ways. What does matter is that you absolutely 100% determine before you do the problem which one is 0.1 and which one is 0.2. Okay. So let's see how this works. So this box 4, there's 2 ways of doing this. Notice they already gave you in red the dashed line there, the distance of the 2 legs of that right triangle. You could use the Pythagorean theorem, right? 3 squared plus 6 squared equals d squared, and then solve that. Or I could use the distance formula. I'm going to choose, your book on homework says solve in any one of 2 ways. So I'm going to choose to use the distance formula here. So this is the distance formula. The number one mistake that kids make when they do the distance formula, there's the 2 points. You see the 2 points, -4, 2, and 2, -1. The number one mistake is that they fail to label. So you need to first pick which one is 0.1 and which one is 0.2. Now, I always pick the first value as 0.1 and the second one is 0.2. A lot of students figure out there might be some I don't know, some strategy involved to deal with fewer negative numbers. For me, I just make the first one 0.1 and the second one 0.2. The second big mistake is that when they label, it doesn't go x1, x2. It goes, because it's a point, it goes x1, y1. And the second point goes x2, y2. You see what I did there? Now it's just plug those numbers into the formula and just be careful because there's negatives involved. So let's see. The formula says d is equal to the square root of, open parentheses, x2. I'm just looking at my labeling. x2 is the value 2. Then there's a minus sign, and then it says x1. x1 is -4. Close your parentheses, and then square it. Plus, let's see, y2 is the value -1 minus, and y2 is the value 2. So if you've never done this before, pause, maybe rewind. Take a long look at where I'm getting those two numbers from. So step number one was I labeled the points, x1, y1, x2, y2. And then I always, when I do these, I have the distance formula written out and I look at it and I make sure I'm plugging the numbers into their correct place. The rest is just a bunch of math. Let's see. 2 minus -4 would be 2 plus 4, which is 6. I got to square that, though. And then -1 minus 2 is -3, and I got to square that. Okay? 6 squared is 36. -3 squared is 9. That gives me 45. And I said we're going to leave this as the exact answer. So is there any perfect square in 45? Sure, 9. The square root of 9 is 3. Okay, so 3 root 5 is the distance between those 2 points. Okay, and you're like, wait a minute, I could have done that a lot easier, 3 squared plus 6 squared. Yeah, because I gave you those numbers. I won't give you those numbers for the rest of the problems. And tonight for homework, they're not going to give them to you either. Tonight for homework, it's going to look more like this. They're going to give you 2 points here, A and B, and they're going to say, what is the distance between point A and point B? Okay? So step number one is label. I got an x coordinate and I got a y coordinate. I got point 1 and point 2. Some students, now I do it this way because they're labeled vertically. Some students will write x1, y1, x2, y2. Either way is fine, okay? All right, so let's see. I got to plug the numbers in. So d is equal to big long square root symbol. x2 is, x coordinate of point 2 is 2. Minus the x coordinate of point 1, which is 3, quantity squared, plus, then I need to do y2, y coordinate of point 2 is 4, minus 8 quantity squared. All right, once again, pause and make sure you agree with me of where I'm getting those numbers from. Okay? All right, the rest is just a little bit of math. 2 minus 1 is negative, 2 minus 1. 2 minus 3 is -1, 4 minus 8 is -4. Once again, we don't need those absolute values because when I square it, it becomes positive. That would be 1 plus 16, which is the square root of 17. And we're done. Okay? If you were very curious, not tonight for homework, I don't want you to do this, but if you were very curious and you're like, well, what is that? You certainly could pull out a calculator, and it's approximately 4.1. Okay, let's do one more. Notice I've already labeled these points here. All right, so I give you 2 points, you label them x1, y1, x2, y2, or like I did right here, xy, then point 1, point 2. For me personally, I'm showing you this. I like this way because it follows a nice pattern. All right, let's see. I need x2. x2 is -4. Oh, we got lots of negatives. Be careful with the negative ones. So I got -4 minus -1, and then -6 minus 3. See the pattern? It goes bottom minus top. Some people will write 0.2 as their first one, and then it's top minus bottom. Okay. Another people just literally just look at the formula and plug in the numbers as it indicates. All right, let's see. -4 minus -1 would be -4 plus 1. -4 plus 1 is -3. And -6 minus 3 is -9. All right, so that's going to give me 9 plus 81. Well, that's 90. And I can see that 9 goes into that, so therefore what? 3 root 10, final answer? Okay, that's not too bad. Tonight for homework, there are a bunch of these. You do need to have some practice here. I forget if I gave you even or odds, but if I gave you all of them, please check the answers in the back of the book. Make sure you're getting the right answers, okay? Generally what happens is that you're dropping negatives. It's really easy to do with the distance formula. Okay, and notice there in yellow there at the very top, I always write the distance formula so I can look at it to make sure I'm not making a mistake. It's really easy to forget which one's minus and which one's plus. It's really easy to make that mistake. All right, let me show you one cool example. So let's just imagine when instead of a line segment, we've got a circle. Okay, so this is actually theorem 13.2, and it says this. Is that the equation of the circle with center AB and radius R is that formula right there. Remember, X and Y there is any point on the circle, and A and B is the center of the circle, and R is the radius. So that is the equation of a circle, right? We have formulas for area of a circle. We have formulas for circumference of a circle, right? We have equations for the graph of a line, right? Y equals mx plus b. Well, it turns out that this is the equation if you want to graph a circle. R squared is equal to the quantity x minus a squared plus y minus b squared, okay? So we can do a lot of things with this. We're going to do basically two things today. We're going to write the equation and we're going to determine things of the circle from the equation. In other words, I'll give you an equation of a circle and you will tell me a couple things about it. So let me show you some examples. All right, so there's an equation. Am I claiming that I'm going to claim that this is the equation of a circle? So if this is the equation of a circle, the instructions say find the center and the radius, meaning how long is the radius? What is its distance? Okay, well, if we know in yellow there, that is the equation of a circle. Well, r is the radius. Well, r squared in our case is 25. Therefore, r must be 5. Where's the center? The center is the A and the B. And notice here, the A and the B is 3 and 4. And you're like, well, why isn't it negative 3? It says x minus 3. Because remember, the formula says x not plus a. It says x minus a, right? So in the equation there, in blue, if the a value is negative, it's actually positive. In the equation there, in blue, if the b value is negative, it's actually positive. Does that make sense? Okay. What was the radius? The radius would be the square root of whatever the equation gives us is the r value. It says r squared value here. I'm just replacing it with a 25. I got to take the square root. So therefore r is 5. Make sense? Okay. Let's see another one. So find the center and the radius of the circle. Okay. So if you need to, write that equation next to it so you can see. So where's the center? Remember, the formula says x minus a. It doesn't say x plus a, but ours says x plus 2. So in this case, the center is not at 2, 6. It's at negative 2, 6. Why? Because our equation says x plus 2. Well, how would you get a plus 2 from the original formula? Only if the a value was negative. So if we plug that negative 2 into the equation for a, it would now read x minus minus 2. Two negatives make a positive, right? So for me, when I'm looking at this, I'm just going to write whatever the opposite is of what I'm given in blue there. Instead of 2, I write negative 2. Instead of 6, I write, instead of negative 6, I write positive 6. Make sense? Oh, what's the radius? Well, you look at the 125 and you simply take the square root. Why am I taking the square root? Well, remember, the equation of the formula doesn't say r is equal to, it says r squared. Okay? So if we take the square root of 125/15, we do in fact find the radius. All right, one more. So there's the equation. Once again, oh, this one has an extra thing. It says to graph it. So it says find the center, find the radius, and then graph it. Well, the first two are pretty simple, right? Well, we know the center is AB and the radius is R, so what's the center? The center here would be careful, would be at 1, negative 2, right? I'm just doing the opposite, right? Instead of minus 1, it's positive 1. Instead of positive 2, it's negative 2. Why? Because the original equation says it's x minus a and y minus b. All right, what's the radius? The radius would be the square root of 9, which is 3. And that says graph. Well, look what it says there in yellow. It says the center is 1, negative 2. I know where that point is, right there. What says the radius is 3? So I count 3 units away from my center there, put a dot. 3 units away, put a dot. 3 units away, put a dot, put a dot. Or I could pull out my compass, measure 3 units, and simply draw a circle. Okay, makes sense? Okay. Now let's do the reverse of that, okay? This time I'm going to give you some information and you are going to write the equation. Remember, the equation of the circle is in this form, right? So if I give you the center and the radius, well, what's the equation? All right, well, let's see how this would work. Well, we know that it doesn't say r, it says r squared. Well, I know the radius is 4, so r squared would be 16. And it doesn't say A, it says minus A. So that would be minus -3. Well, that would be plus 3. And it doesn't say B, it says minus B. So minus -6 would be plus 6. In other words, once again, the opposite. Is that starting to make sense? Let's do another one. All right. What's the equation if the center is that and the radius is that? Well, formula doesn't say r, it says r squared, so square the radius. Square root of 7 squared would be what? 7, right? And then I write the opposite of a and b. I'm given 10, -6, so the opposite of that would be -10, and the opposite of -6 would be plus 6. Is that starting to make sense? All right. This isn't that complicated. All right, last one. Okay, so I'm given this is the center. I'm given this as the radius. What's the formula? Well, I got to square the radius. So the square of the radius would be 4/9. And then instead of a, I write -a. Instead of b, I write -b. So that would be +11 and a -3. And there's your equation. I know a couple of you probably, as soon as I say, well, how would you graph this, might have grabbed your graphing calculator and seen if you could graph r squared is equal to blah, 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 blah. And you run into a problem. The problem is this, is that your graphing calculator, right, doesn't say r squared equals, right? It says something like y is equal to. So here's what I want you to do. Grab your graphing calculators, and I want you to graph these two equations, right? Now, notice your graphing calculator always says y equals, right? So in yellow there is what I want you to graph, right? The blue there is just the generic equation, okay? So in yellow there, I want you to graph those two functions right there. Y is equal to the square root of 16 minus x squared, and y is equal to negative square root of 16 minus x squared. After you've graphed this, now yours might look more egg-shaped, right? You have to change the zoom to zoom square for it to look more like a circle. So the question is, why is that in yellow? Why is that the equation of the circle when you just spent a whole lot of time telling us that the equation is actually r squared is equal to the formula? Okay, and the reason for it is this: your calculator only graphs functions, right? And a circle is not a function, right? So that is the equation that I gave you in class, right? But your calculator says it when you type things in, it wants to see either y equals or f of x is equal to. It wants a function. Why? Well, circle is not a function, right? It fails the vertical line test, right? Remember the vertical line test? If a vertical line touches a shape in 2 or more spots, it is not a function. So notice all circles fail this. So what we did there was basically take the circle, cut it in half horizontally. So we have an upper portion looks like a frown, and a lower portion looks like a smile, and those two are functions, because then the vertical line would only touch in one spot. So it's kind of a trick. But I will say that the formula I just used does come from that blue formula. So this is just discussion, right? It's not part of the formal class or what you need to remember, but I do want to show you where it comes from. So if we made a circle where the circle is centered on the origin, where the center is always 0, 0, right? It would look like that equation right there, right? A and B would both be 0 because it's centered at the origin. Well, x minus 0 is x, and y minus 0 is y. Therefore, it would be that equation right there. Okay, all I'm doing is we're writing an equation for a circle that is centered at 0, 0. So remember, we were trying to get it to say y equals. So we can do this a little bit easy. Subtract x squared from both sides. So I'm going to subtract x squared from both sides, right? Notice I put the y squared on the left there. Okay, and then we simply take the square root of both sides. Now remember, when you take the square root, right, you get a positive and a negative value, okay? And that kind of looks like the equation that I just gave you. In fact, it is. I'm just going to break it up into two parts. Y is equal to plus the square root of r squared minus x squared, and y is equal to negative square root of r squared minus x squared. And in yellow there is what I had you graph. So r would be the radius, right? So that's why it was 16. So it was a circle centered at 0 with a radius of 4, right? You did a 16. So that's kind of cool. So that's how you graph circles on a graphing calculator. All right. So that'll conclude the class for today. There's your homework. It's pretty straightforward. There's nothing really challenging about tonight's homework. I'm not sure why the difficulty kind of slopes down towards the end of the geometry book, but we are definitely on the down slope for how challenging the material is. You're going to tear through tonight's homework. All right, I will. If you have any questions on the schedule or anything like that, please email me. And if you have any questions on the material, you can do that as well too. I'll see you guys on Friday.